Hello, my name is Izzy Rivera. I'm going to give you a demonstration of a meter that we've created for power stations, HRSG, heat recovery steam generator type of power stations, and we've customized a meter to help them solve an issue that they have. The issue that they have is that when the plant is first being ramped up, they may get condensate in the steam tubes. As a result of the plant, when the plant was ramped down, and this condensate in the tubes creates a dangerous situation when it hits the boilers. It expands very rapidly. It can cause tube fatigue and tube failure. After we have sponsored some testing, where they're looking for a device that can detect when the pipes are full of condensate, so that they can automatically dump that condensate from the pipe when they start up the power plant. So we've developed this specialty meter. Now this here is our wave injector device. We use this device for very high temperature pipes. So this can go up to 800 degrees. These applications run from 500 degrees to 800 degrees, and what this does is it puts our sensor on the top of this waveguide plate so that the sensor doesn't make direct contact with the pipe. So we've set up this pipe, and this is a pipe of the same dimensions that's typically used. It's an extra heavy wall pipe, 3-inch extra heavy wall pipe. And what we've done is we filled this pipe about 3/4 of the way, and what we're going to do is demonstrate how the meter detects when there's water in the pipe. But when we spin the pipe, then the beams will be at the horizontal point, and it'll be filled with water. And then in this position right here, there's a water void on the top of the pipe, and so it shouldn't be seeing liquid. That would be the simulation of an empty pipe condition. So here's the meter here, and the way this meter is now designed to work for this type of application is it works on the dB signal, and when the signal has an empty pipe, then the dB signal is low. It should be around 1, close to 0, maybe a little bit negative. There's also an amplitude signal here that's just raw amplitude, so that gives us a little bit diagnostic of the health of the meter. And so when we spin that pipe, this dB is going to go up to maybe 20, and we set a threshold point at, let's say, 10, and that would cause the alarm to occur. So now I'll spin the pipe, okay, and you can hear an audible alarm that just went off. That's being triggered by our relay inside this meter. You can see that the SCNR has gone up to 26 decibels, and that means the pipe is full with water, and they have to dump the water out of the pipe. Well, as they're starting up the plant, when they get to a point where there's water no longer in the pipe, they get back to an empty pipe condition. Now it's just steam in the line. We lose the signal dB goes down, and the alarm goes off, and they can stop dumping liquid. So that's just a demonstration of a Flexim meter, custom design for these specialty type of HRSG power plants that have this issue and that they're looking for a solution for.